Hi, welcome back to another lesson with Domoji Math and Science. In today's lesson, we'll continue with our lesson on equilibrium. We'll use an example to demonstrate how to solve questions relating to non-parallel coplanar forces. That said, let's get started. Our example says a body of mass 10 kg is kept in equilibrium by two ropes. Now, here are the two ropes. You see, this is a rope and here is the second rope. Obviously, the body of mass 10 kg is at the center. This is a body of mass 10 kg. If one rope pulls this body in an horizontal direction, this rope is pulling it in an horizontal direction, and the other in a direction of 40 degrees. This is the direction of 40 degrees with the vertical. That is, this is 40 degrees with the vertical. Calculate the tension in each rope. That is, I'm to look for the tension in T1 and the tension in T2. Now, one unique thing we must observe is that this body is kept at equilibrium. And for this body to be kept at equilibrium, that is, the summation of our force on the x-axis must be equal to 0, and the summation of our force on the y-axis must be equal to 0. Now, the weight of the body hangs down at 10 kg of mass. That means if the mass is 10 kg, if the mass of the body is equal to 10 kg, the weight will be equal to mass times acceleration. That's 10 kg times 10 meters per second squared, which is equal to 100 newtons. Now, that means the body has a weight of 100 newton. Now, let's resolve. Already we have the weight acting vertically downwards, and we have an horizontal tension. We have a force T1 that is hooked at 10 degrees to the vertical. Now, let's resolve this force to both the vertical and the horizontal. Now, on the vertical axis, I can resolve this to vertical. This will be, let's call this my Tx, that's the horizontal component, and the vertical component, let's call it my what? My Ty. Now, from Pythagoras theorem, if you look at this carefully, I already have a triangle this way. Here I have Tx, and here I have what? Ty. While the angle of 40 degrees is here, and I have my T1. Now, from Pythagoras, from SOHCAHTOA, I know that my Ty over T1 is equals to cos 40. My Ty will be equals to T1 cos 40. And my Tx invariably will be equals to T1 sine 40. For this body to be at equilibrium, summation of f of x must be equals to 0, and summation of f of y must be equals to 0. Now, let's look at our f of x. My f of x will come from T2 and Tx. That's T2 and Tx. And that is, my f of x will come from T2 minus Tx to be equals to 0. They are both in different direction. So that my T2 minus Tx is the same thing as T1 sine 40 is equals to 0. So that T2 will be equals to T1 sine 40. On my y-axis, I shall have T1 or Ty minus 100 to be equals to 0. So that Ty is equals to 100. Ty now is equals to T1 cos 40. That means 100 will be equals to T1 cos 40. So that 100 all over cos 40 is equals to T1, which is the same thing as 100 over 766. That equals 130.548 in Newton. Now, if T1 is equals to 130.548 in Newton, our T2 is given as T1 sine 40. So that T2 will be equals to 130.548 into sine 40, which is equals to 130.548 into 0.643 approximately. So that T2 will be equals to 83.915 in Newton. Now, so with this, we have been able to solve this question, and in our next lesson, we will create more examples to demonstrate how to treat non-parallel coplanar forces. Thank you for staying with us, and do not hesitate to hit the subscribe button. Thank you, and see you in our next class.